versus non-static variables in methods. So first let's consider the following example. We have a class called register, which is a register at a store, and it has a private variable to record the total amount of that register, of the total amount of the transactions of that register on that day. It has a method to add cash, where you pass the double variable amount, and that amount gets added to the register's total. Then you have a variable called take cash, which is when people give change or whatnot, take cash from the register. So you take some amount that is then subtracted from the register's total. Again, and then you have a method to get the register total, right? That just returns that variable. It returns a double, as it is noted here. And that is because rect total is private, so it cannot be accessed any other ways but with that method. So a class register that can add cash, take cash, and get the total of that register at the end of the day. We also have a store class, public class store, with a method. This is a store where I will create 3 different registers, right? So register number 1, R1, is equal to a new register. That's how I create one with a total of 0, with a register total of 0. A register number 2 with a register total of 0, register number 3 with a register total of 0. Because these variables are initialized here, the register total is initialized when you say new register, and it's initialized to 0. So let's assume that during the day these were the transactions. R1 added 34.5, then R2, so somebody was buying an R2 and paid 12.99. Then at register 3 they paid 5.99. Then at register 1 they paid 6.95. Then at register 3 somebody again bought something for $1.01. But then register 2 actually, when it received some amount, it had to actually give some change. It had to give 99 cents of change. So we're going to print at the end of the day what's the total in each of the registers, okay, and each of the registers. So for example here, system out print line R1 plus whatever the get total for the get rect total for R1 is. The same for the register 2 and the same for register 3. And then we're going to have, because I'm the owner of the store and I'm interested in the total, the total money that I have, I'm going to create a variable store total where I will just add the total from register 1, the total from register 2, and the total from register 3. Remember that these method calls will result to a number, so it's okay to have them in between plus signs. You don't have to have a double variable for each one of these separated. And then we will print the store total, which is just this line, right? So we'll compile this and run it, and we'll see in our output area here that we have in the register 1 we have $41, which was 34 added 34.5 plus 6.95, that would be 41, right? 34.05 plus 6.95 is 41. Similarly, we have register 2 is 12 and register 3 has 7, and the store total is $60. Okay, the store has now $60. Now, I'm going to explain a little bit of something that happens in the Java virtual machine. So if you pay attention to this graph here that I have, okay, when you create a new register object, new object, right, you have a name, R1, okay, register 1. There are 2 areas of memory in the Java virtual machine that are relevant here, the heap and the method area. The heap, sometimes also some people call it the object area. The heap is divided into the handle pool and the object pool. The handle pool has basically, pointers to where your class is, right? So here is the reference, the name of the class. In the case of register 1 would be R1. R1 points to an area in memory where there's something really interesting. All the methods in the class are stored in a different area of memory called the method area. A lot of the class data, including methods, okay? And then the variables for each individual, because the methods are shared among all the instances of the class, right? So the method add cache is the is the same. It just uses a different instance of the class, but it's the same definition. So all the method data comes here, and all the instance variables go into something called the object pool, which is inside the heap. So every time you create R1, register 2, or register 3, or R3, you will be creating the register total variable, which is unique to each instance. You'll be creating those variables here. You'll be creating anything that's instance data over here. Anything that is a method will go to this class data. But not only method can go to this class data, to this common area, okay? There can be other things in this class data. Now, as a last, staying in this picture for the last time, when you have a register R1, you'll create R1. You will point into all the instance data of R1, which in this case is just the register total. And you will have a pointer to the register class, which contains the definitions of the methods, which use that instance data. Then you create R2. Then in the heap, you're creating a pointer to, in this case, this instance data, so the reg total of register 2. But then you point to the same methods of the class, the methods that are common. Okay? So this is how classes are divided in memory. Now let's see how this will work if we were to trace this program. So let's go into tracing this program. So register R1, new register 1. So let's say we have, in this case, I'm going to try to move this a bit so I can see my program better, and then I'm going to trace it over here. I create my heap and my method area. So register 1 equals R1. Okay, so I'm going to create a register R1. That'll be here. Boom, I create an object register 1, right? So I'm gonna name it. Can I change this? Yes, register, this will be R1. Okay, and the register total of R1 is 0 at this point. Then I go here and create register 2, a new register. Okay, so what I'll do is I will create a new register that I will conveniently call register 2, or 2, and register total equals to 0. At the same time, by the way, I'm also creating an instance in the method area, an instance of the register class. Here, not an instance, but all the common definitions of the register class. And I forgot one little line that divides this. There you go. So we'll have to create a common, everything that's common in the register area. The methods definitions are going to be here, for example. Okay? All right, let's go. Now, register R3. I create a new register here called R3. So I create a new instance of a register class called R3. So this will be R3, and the register total, as usual, is 0. Then I'm going to go here, add cache 34.05 for R1. So add cache will increase the register total by 34.05. Then the next line says R2 add cache 12.99. So we go to R2 and we add 12.99. Then the next line says R3 add cache 5.99. R3 add cache 5.99. Okay, and then I just print out the different things. Oh, I'm sorry, 5.99. Sorry, R1. Then I add more cache, 6.95. R1 I'll add 6.95, which will give me a total of 41.0. And then R3 I will add cache 1.01. So R3 I'm gonna add 1.01, which gives me $7. 7, and this 41 should probably have 2 zeros here. So $7, and then I'm going to take 0.99 from R2. So if I take 0.99 from R2, I am left with $12 sharp, right? So this is basically the state of the classes at the end. So when I go to print, I print R1 get reg total will be 41, R2 get register total will be 12, R3 get register total will be $7, right? And then I'll get the store total and everything. So now what we're going to do is, I am interested in computing the total number here, right? But if I add another register here, if I add another register, like shear register, and I start adding transactions, to compute the total I will have to modify this line as well. And I will have to always remember to modify this line. Well, my goal now is going to be to actually not have to modify that the total, this line in this case, the line that stores the total, but actually make use of this common area to store the total all the time. To do that, what I do is I can add, for example, a public, I'm going to say public static, a static variable here, okay, static variable, it's going to be a double, and it's going to be store total, okay? So then when I add cache to the register total, right? But also to the store total, I also add this amount, okay? To store total, I also add this amount. And then, for example, for take cache, I'm going to go to store total and subtract this amount, okay? And then I'll return get register total, that's fine. We'll see how to get the store total. We might not need a method for this one because it's public, okay? Now, let's go to the store now. Let's trace this program at this point, okay? We're going to create 3 registers. We're going to add cache and take cache, but now the add cache and take cache will change a static variable. So what's going to happen now is I'm going to put this class up. You know that I will create R1, R2, R3 at this point. So I'll create R1, R2, R3. This will be initialized to 0. But look what's going to happen at this point. Something really interesting. What's going to happen is, because one of my variables is static, namely my store total is a static variable. Let me move it over a little bit more so we can see both there. So static double store total. If it's static, okay, then a variable called store total, for each one of the instances, for each one of these, and this, what's going to happen is when I create the class in the method area, I'm going to put a variable called store total. And for each one of these instances that I've created, a store total pointer is going to appear. Store total pointer. Store total pointer. This is not exactly how it happens, but it's pretty close. So whenever I do something on register 1, if I do something on the reg total, it's going to change this number here. But if I do something on the store total, it's actually going to go up to the method area's store total, and it's going to change that variable. So let's see what happens here. Let me go back to my store program. Again, we said that whenever you add cache or take cache, that modifies the register total and the store total. Okay, so let's go over this again. We go R1 add cache 34.05. So we'll add the cache 34.05 and register 1. Now this method add cache is now adding to the store total. Oh, store total is over here, so we'll add 34.05 here. 34.05 here. Okay, so I'm going to move this a little bit there. 34.05. Then I go to, in my program, R2 add cache 12.99. So I will add here 12.99. But that also adds to the store total, which points to this variable. So I'm going to add 12.99 here, and that is going to give me 12.99 plus 12.99 plus 34.05, right? 34.05. If you do this computation, you get 47.04. Oops. You get, whoa! You get 37.04, 47.04. Okay. Then I'm going to go to register 3 at cash 5.99. So I'll add 5.99 here, 5.99. And because I'm also adding to a store total, which points over here, I'm going to add 5.99 to this number, which gives me 53.3. So let's add this plus 5.99, that would be 53.03. All right. Then I'm going to add again to cashier 1, R1, at 6.95. I will add 6.95 here, which leaves me with 41, and 6.95 over here. The line highlighted is misleading. There you go. 6.95 over here, which will result in 59.98. So 59.98. Then I'm going to go to this line, R3. I'm going to add cash 1.01 to R3. Adding 1.01 gives me $7 here. And adding 1.01 to the store, remember I'm adding to a store total which points over here. I'm going to add 1.01 here, which gives me 60.99. So 60.99. Then the last line, R2, I'm going to take cash. I'm going to take 99 cents out of R2. So that will give me $12. And because I'm taking also 0.99 cents from the store total, which points to this one, I'm going to take 99 cents from this one, which gives me $60. Okay? Therefore, in my method area, the store total will be $60. And the individual registers have their own total. Now, the next question is, how do we access this store total? Well, these are called the method area or class data. This is class data. So this is, again, instances. The instances are R1, R2, R3, but the class is register. So if this variable store total is static and it's a class variable, I can just access it with the name of the class. So look at what I'm going to do here. Instead of doing this double store total line, which can still work, what I'm going to do here is I'm going to say the name of the class, register dot store total. I can do this because store total is static, is a class variable, is not an instance, is not tied to R1 or 2 or 3 or any other instance, it's tied to the class. So I can do this kind of things. So I'm going to compile this, and now I'm going to bring this back here, and I'm going to run this. And we get the same thing we got before, 41 for register 1, 12, and 7, and then the store total is 60, which matches perfectly with this. Store total is 60, 41, 12, and 7. This is what a static variable does. It's a variable that stays the same and is common, is shared among all instances of a class, and can be accessed just using the class name. If it's, of course, if it's public. If it's private, you will need a method to access it, but it will be a method of the class. You can say register dot and then access that. Let's create a method to access this variable. Now, because this variable is part of the class, okay, it's part of the class, I cannot just access it. The method that accesses it has to be also a method that can be used from the class. And that means creating a static method. So in my register class, I'm going to create a static method, public static, okay, double get store total. And what this is going to do is this is going to return the store total. Okay? Now, because this method is static, this variable here that I'm getting from outside of this method must be static as well. Okay? So then everything that I do with static can be done from the class and does not need an instance. Okay? That's what this should do. So if I compile this and then compile this guy, whoops, and then here in register, instead of store total, okay, what I'm going to do is I'm going to call this method get store total. I'll compile this, run it, and I get the same thing. 41, 12, 7, and the store total is 70. But notice that this method, because it's static, I can call it from just the class name. Many times you might have used static methods. When you do system.out, that's a static variable. Okay, that's a static variable that you're calling. When you do something like, I'm just going to write here for the sake of writing, when you do math.pow and then 2, 3, for example, that raises 2 to the power of 3. When you say this is the class name, math.pow, pow is a static method. Static methods are usually used when you don't need to actually instantiate a class. You just need to find an operation and get the result, for example. Okay? And work with the results, and that's all you need to do. This is a static method. Static variables can be used to trace, for example, how many instances are open, or trace a total like this, or just create strings. We'll see this later on, but just create strings that can be used across the other classes. You'll see this later.